Very good. Molarity Introduction notes. This should be the first lecture in week 3. We'll start by defining concentration. A solution's concentration is a measure of how much solute is dissolved in how much solvent. A review of last week's lecture will remind you that a solute is what is being dissolved. A solute can be a liquid or it can be a solid. The solvent is generally a liquid, and this is what is doing the dissolving in a solution. A high concentration means there's a lot of solute. Low concentration means there is not a lot of solute. Concentration can be measured in a number of different ways. We will start by familiarizing ourselves with the most common technique, which is molarity. Molarity is the measurement of how many moles of solute are dissolved in liters of solvent. The definition of molarity is that it's a ratio of the amount of moles of solute dissolved in liters of solvent. To find this ratio, you divide by the amount of moles of solute by the liters of solvent. Molarity has 3 different equations associated with it, depending on the different measurements you want to find. We'll start with the most general, to the far left. Molarity equals the number of moles divided by liters. In the middle, if you're solving for liters, you take the number of moles and you divide by the molarity. Lastly, in the far right, if you want to find the number of moles, you take the number of liters and you multiply by the molarity. For these equations, you need to have liters or moles to solve them. Problems may give you measurements of solvents in milliliters, for example. To convert milliliters to liters, you will have to divide that measurement by 1,000. You also may be given grams of solute in a problem. To find the moles of solute, remember you have to divide the grams of solute by the molar mass from the periodic table. Let's begin a short molarity practice. If Ricky dissolves 4.25 moles of NaCl in 1.25 liters of water, what is the molarity? To solve this problem, use equation number 1 in the far left. Molarity equals moles divided by liters. Ricky has 4.25 moles, and we are dividing it by the solvent, 1.25 liters of water. This is a division problem. We obtain 3.4 molarity. Next problem. Penelope uses 0.750 liters of water to create a 0.86 molarity solution of KCl. How many moles of KCl were used? To solve this problem, we use equation number 3 in the far right. We're looking for the number of moles, so we will take the number of liters and multiply by the molarity. Therefore, the number of liters was 0.75 liters of water, and we're multiplying that by the molarity. 0.86 molarity. That was a typo. (0.75) times 0.86 gives us 0.65 moles. You might get a longer molarity practice. For these problems, you will need to convert given milliliters to liters or given grams to moles. For example, Kennedy works in the lab with 675 milliliters of water in the lab. If he wants to make a solution with a molarity of 1.15 molarity, how many moles of solute should he use? We will be using equation number 3 in the far right to find the moles. Remember, moles equals liter times molarity. But before we can start, we have to do some unit conversion. We have to convert the milliliters to liters. So we're dividing them by 1,000. We take 675 milliliters and divide that by 1,000 to obtain 0.675 liters, which is what we want. Now we can plug it in. 1.15 molarity times 0.675 milliliters gives us what we want, 0.776 moles. Next long problem. Tricia dissolves 43.8 grams of NaCl to make a solution with a molarity of 1.5 molarity. How many liters of water did she use? We will require equation number 2, the one in the middle, to find the liters. Liters equals moles divided by molarity. But before we can do this, we have to convert the given grams into moles. We start out by putting 43.8 grams, and we are going to divide by the molar mass of NaCl, which is 58.44 grams. We obtain 0.749 moles of NaCl. Now we can plug in the moles into the equation. We take the number of moles, 0.749 moles, and divide them by the molarity, which was 1.5 molarity, to obtain our answer, 0.5 liters.